Hello everyone, I'm Dhruv, a PhD student at Georgia Tech, and today I'll talk about investigating local network communications on websites. This is work in collaboration with my advisor, Frank Lee. In May of last year, there was chatter on Twitter in which users and security practitioners were complaining that eBay was using client-side scripts to port scan their localhost. Here is a screenshot tweeted by a cybersecurity blogger in which they show that they found eBay to be scanning 14 ports on their localhost. That made us wonder what's going on and how widespread might this be on the web? Are there websites out there which are communicating with their visitors' local resources? Here, by a local resource, we mean any address on the user's local area network, that is the LAN, or the user's own machine, that's the local host. And to study this, we set out to systematically measure and characterize this behavior on the web. Today, let's focus our attention on two broad research questions. Which websites are trying to communicate with the user's local resources? So we want to see if websites are actually trying to communicate with them, and if they do, then we want to investigate the reasons behind such communication. And you can find much more detailed analysis in the richer discussion in our paper. Let me start by describing our method briefly. For a comprehensive view in our study, we measured both popular websites as well as known malicious pages. For popular websites, we measured landing pages of the TrianCode top 100,000 domains twice, approximately a year apart. We also used popular blacklists to collect about 145,000 known malicious URLs spanning categories such as malware abuse and phishing. Next, to capture requests made by websites to local resources, we crawl each website with a Chrome browser and we crawl multiple websites in parallel using multiple virtual machines. Each of the virtual machines runs one browser instance at a time. And we wait 20 seconds for the page to load and run its client-side code while we log the network requests it makes. We also wanted to capture how this activity varies across operating systems. So we ran our crawls on a Georgia Tech server using multiple Ubuntu and Windows virtual machines. For Mac, we similarly run our crawls on a MacBook Air placed inside a residential network. Finally, we parse and store more than 11 terabytes of network telemetry that we collect directly from Chrome's network stack. Before jumping into the results, I'd like to take a moment to discuss some limitations to our study. Our measurements are conducted using Google Chrome and 3 desktop operating systems, which are widely available and popular. However, websites may behave differently on other browsers and operating systems, such as mobile operating systems, and this can be explored in future studies. We only fetch the landing pages of top domains, and our crawler does not simulate user interactions with the web pages. As a consequence, our data does not capture the behavior of internal websites, nor activity triggered by user actions. Thus, the number of domains for which we identify local network activity is actually a lower bound to the true number of websites exhibiting such behavior. We also monitor the web page only for 20 seconds, which we justify as a reasonable threshold in the paper. So we do not detect any activity that commences after that. Lastly, we execute our crawls using an academic and a residential internet service provider, and we did not identify any significant network-based discrepancies. In theory, though, we recognize that websites also might behave differently based on different geolocations and internet service providers. Now, coming back to our research questions. To look at which websites, let's look at the aggregate statistics. For the popular websites, we found about 100 web pages communicating with the user's local host and about 10 web pages making LAN requests. This shows that this odd activity is clearly not common yet, but since it is a non-trivial number of highly ranked sites, including several within the top 10,000, we are curious to see why. As for malicious pages, the trend generally holds true for malware and abuse, but interestingly, we found a higher number of phishing sites requesting a resource on the user's local host. This is something that we'll explore soon. And just to give you a few examples, popular websites involved in this activity include e-commerce sites like eBay and Betfair, banking sites like Citibank, portals to various governments, as well as general purpose consumer services. Okay, so we found a fair number of sites doing this. Now let's dive in a bit deeper into the reasons behind this activity. Let's look at the same example as we saw in the tweet. In our measurement as well, we found localhost requests being generated by eBay. We follow these requests to the JavaScript file that initiates them, and we see that the code is in fact pinging the ports and inferring whether a service is running on them or not, based on the time it takes for them to receive a response back. These attacks are commonly known as timing attacks. And digging in a bit deeper, it makes it very clear and explicit that they're looking for specific remote desktop services such as VNC and the remote desktop protocol. Finally, we found that the script is being served by a service called Threat Matrix, which performs fraud detection and is owned by LexisNexis, a cybersecurity company. So in a nutshell, we found that a set of 36 sites use this service that pings 14 ports known to be used by remote desktop servers, and this happens only if a user is visiting using a Windows machine. These sites include major banks like Citibank, and as we saw earlier, e-commerce sites like eBay. Surprisingly, we also saw a good number of phishing websites using this service and making the same localhost requests. Inspecting their code closely, it was clear that these phishing websites had actually inherited the client-side code from the legitimate websites that they had cloned. So for example, if an attacker wants to phish the victim's Citibank credentials, they could use a phishing kit and clone Citibank's user interface. This is what's happening here. This also explains why we saw a higher rate of phishing pages involved in local activity. Another interesting finding was that the service used the WebSockets protocol, which is not bound by the same origin policy and hence opens up the possibility of bidirectional communication. And while some of the service sites stopped using the service in 2021, most of them continued. Investigating similarly, we find that some sites do it for bot detection. Specifically, we found about 10 sites, majority of which are portals to government websites, using a service called Bot Defense by F5, a cybersecurity company. This too was observed only on Windows, and in this case, it pinged 7 ports known to be used by particular botnets and browser automation software. Interestingly, we saw this activity only in the 2020 crawls. All the websites stopped using this service when we crawled them in 2021, but it was not clear why, despite the service still being available. There is also a legitimate use case for websites to communicate with the user's local host. That is, when a website wants to communicate with their own native application on the user's machine. For example, when you click on a Zoom call link, the browser prompts you to open the Zoom app. This is enabled by a Zoom server running on the local host with which the browser can communicate. We found this activity almost uniformly over all operating systems and utilizing both HTTP and WebSockets protocols. Finally, we also observed websites making local requests for various files, which seem to be hosted at a local server during development. For example, at the bottom, we see a style attribute of an HTML tag referencing an image clearly hosted on a server on the localhost port 8888. This looks like an error made by a developer while deploying the website, in which they just forgot to change the server address from localhost. We classify these requests as likely developer errors and think that they should be easy to fix. This in fact explains the local network activity for a majority of the sites. So to sum it up, we uncover a non-trivial amount of local network activity with hundreds of websites generating requests to local destinations. We found that certain well-known websites are already profiling users' hosts, especially targeted at Windows users. And though this profiling for risk assessment might seem innocuous at first, it can very well be extended to potentially unfavorable use cases, such as tracking the users across the web. We already see evidence of services using the WebSockets protocol to detect available ports, circumventing the same origin policy, even if bidirectional communication would not be available. But looking ahead, the browser security community has recently started proposing modifications to the Fetch API to mitigate such unintended exposure to the local network. We hope that our study helps inform how websites may be interacting with local resources and guide efforts to help protect user local resources from websites moving forward. Please find our paper at the link below and feel free to reach out to me for any questions. Thank you.